State Bohr's quantization condition of angular momentum. Calculate the shortest wavelength of the bracket series and state to which part of the electromagnetic spectrum does it belong. Okay, first we'll see the Bohr's quantization. The Bohr's quantization condition of angular momentum. According to Bohr, electron can revolve in certain discrete orbits called stationary orbits. Where the orbits are revolve, that orbits we call it as stationary orbits. The total angular momentum L of the revolving electron is a integral multiple of h divided by 2 pi, where h is a Planck's constant. Okay, then according to this we can write this equation, that is 1 upon lambda is equal to R times 1 upon nf square minus ni minus 1 upon ni square. From bracket series, the shortest wavelength is for the transition of electrons from. Then we can assume ni is equal to infinity to nf is equal to 4. Then we can substitute the values. 1 upon lambda is equal to R times 1 by 4 square, which is nothing but R by 16. Then lambda is equal to 16 by R. Then we can write this as 1458.5 nanometer on substitution of value of R. Second part of the question. Calculate the orbital period of the electron in the first excited state of hydrogen atom. Here we can solve this one with some data like radius. The radius Rn is equal to h square epsilon naught divided by pi times m e square into n square. And velocity Vn is equal to 2 pi e square divided by 4 pi epsilon naught times h into 1 by n. Then the time period Tn is equal to 2 pi Rn divided by Vn. Then we can write this one as 4 epsilon naught square h cube n cube divided by m e to the power of 4. For first excited state of hydrogen atom, n is equal to 2, where n is equal to 2 for first excited state of hydrogen atom, then T2 is equal to 32 epsilon naught square h to the power of 3 divided by m e to the power of 4. N is nothing but 2 here. N is nothing but 2. 2 cube is 8. 8 fours are 32. Epsilon naught square h cube divided by m e to the power of 4. On calculating, we get here T2 is equal to approximately 1.22 into 10 to the power of minus 15 seconds.